Hi everyone! In this video, we will discuss more on the concept and theory of atoms and molecules in the chapter of matter. The concept I will discuss will be the proton, electron, neutron as subatomic particles, and also you will learn on how to identify the proton number Z, neutron number A, and isotope together with the way to write the isotopic notation. And also we will try to do some example of calculation related to today's content. So please stay with me until the end of the video. Do you know what is inside a matter? So let's take an apple as the example. So if we enlarge one tiny spot in apple, you can identify the element inside the apple. And by knowing the element of the apple, you can identify its atom. And in its atom, we can find the nucleus. Atom is the tiny particle or smallest unit that made up of matter. So what are the subatomic particles? We have three subatomic particles. They are proton that carries positive charge, neutron that carry no charge or neutral, and the other one is electron. So both proton and neutron is located in the nucleus. They are densely packed in the nucleus. Meanwhile, the electron is located outside the nucleus, to be specific in its orbit, and electrons are moving around the nucleus. Electron will carry negative charge, proton carries positive charge, neutron having no charge, which is neutral. Okay, and these two are located in the nucleus. You can see that at the center of the atom here is the nucleus. So the nucleus consists of proton and neutron, both proton that having positive charge, neutron having zero charge or neutral, and electron that having negative charge. Nucleon is particle that are found in the nucleus. It consists of proton and neutron. Element can be identified by its proton number. So every element in the periodic table are different because they have different proton number. So these are the information, some informations of the subatomic particles that you need to know. So we have electron, proton, and neutron with their respective mass, charge in coulomb, and charge in units. So for electron, the charge is -1, proton is +1, and neutron is neutral, so which is 0. And you can see from the mass of these three subatomic particles, proton and neutron are heavier than the electron. Okay, proton and neutron is heavier than the electron. So this is the reason why the mass of an atom is concentrated in its nucleus, because in the nucleus we have proton and neutron. The number of electron equals to the number of proton in atom. So this is the reason why atom is an electrically neutral species. And you have seen in the previous slides regarding the mass of the electron, proton, and neutron. It seems the mass of the proton and neutron is heavier than the mass of the electron. So mass of proton and neutron will contribute to the mass of an atom. Okay. Mass of an atom is concentrated in its nucleus. So from the atom, so now we go to the atomic notation. Okay, atomic notation is actually the symbol that we use to symbolize information of the atom. So in atomic notation, we have this atomic symbol. So X is the atomic symbol. So we may substitute with any element such as sodium, carbon, and so on. And A is the mass number. So what is the mass number? Mass number is number of proton and number of neutron. So A equals to number of proton, which is Z, plus with N, okay, which is number of neutron. And what is Z? So Z is the atomic number or number of proton in atom. So this is an example of carbon atom. So carbon is the symbol of the element or atom. Okay, C is the symbol of carbon element or atom, and 12 is the mass number, 6 is the atomic number. So how we can get the 12? So 12 is actually from the additions of 6 proton number and 6 neutron number. So 6 plus 6, you will get 12 mass number, and the number of 6 over here is actually belongs to number of protons. So mass number is also known as nucleon number. Atomic number also refers to proton number. And in neutral atom, proton number equals to number of electron. Okay, so carbon here does not have any charges over here, meaning that this carbon is a neutral atom. So for the neutral atom, number of proton over here is equals to number of electrons. But if we have charge for this atom, whether positive or negative charge over here, so now number of proton is no longer equals to number of electrons. So suppose that we have this atomic notation. So to find number of proton, you have to refer to this value at the bottom. So this is the value of Z, which is number of proton. And then to get number of neutron, you have to refer to the value at the top, which is mass number or nucleon number. So mass number is Z plus N. Okay, and N is the number of neutron. So in order to find number of neutron, so that will be A minus Z. So we have 90 minus 38. So the answer will be 52. And the last one will be number of electron. So for this atomic notation, you can see that on top of here, there will be no charge on the atom. Okay, meaning that this atom is a neutral atom. So for the neutral atom, number of electron equals to number of proton. So in order to get number of electron, the value of electron will be equals to the proton number, so which is 38. Next, we move to ions. There are two types of ions. We have cation and anion. So cation is formed when the neutral atom loses its electrons. So when the neutral atom loses its electrons, hence we will get cation. So what is cation? Cation is positive ion. And when the neutral atom gain some electron or electrons, so we will form an ion. So an ion is actually the negative ion. And we have two types of ions, monoatomic ion and polyatomic ion. Monoatomic, mono means one, single. So monoatomic ion refers to ion that contains of only one type of atom. For example, sodium plus, chlorine minus, calcium 2 plus, oxygen ion, and so on. And for polyatomic ions, this one is refers to ions that contains more than one type of atom. Okay, for example, hydroxide ion, OH minus, consists of oxygen and hydrogen. Okay, cyanide ion, Cn minus, ammonium ion, NH4 plus, and many more. So this is a neutral fluorine atom. So in neutral fluorine atom, it has 9 proton number, and for neutral atom, the number of electron will equals to the number of proton. So when this fluorine atom accept 1 electron, so now fluorine atom will become fluorine ion. So for fluorine ion, the number of proton here will be the same, exactly the same, but now the number of electron is no longer equals to the number of proton. So for the number of electron, it will become 10 electrons. So meaning that here, when we form the anion, for an ion, number of electrons are more than the proton number. Okay, next example will be calcium atom. So for the neutral calcium atom, it has 20 proton number and also it has 20 electrons. So this is for neutral atom of calcium. So after the calcium lose or donate electrons, okay, how much electron loses? 2 electrons loses from the calcium atom. So now calcium atom will become cation, calcium 2+. So in calcium cation, the number of proton will be exactly the same. Number of proton does not affected when the atom forming an ion or cation. So number of proton will remains the same. But now the number of electron will be lesser. So for cation, number of electron will be less than proton number. Now let's try this example. We have cation Al3+ and anion Cl-. So for the Al3+, in order to get the number of proton, you should refer to the value at the bottom. So number of proton equals to 13. And in order to get number of neutron, it is A minus Z. So we have 27 minus 13. So the answer will be 14 for number of neutron. In cation, number of electron is less than proton number. So to get number of electrons, you have to do proton number minus the charge. In this case, 13 minus 3 will get 10 for number of electrons. And also, to get the charge of the cation, we can simply do proton number minus number of electrons. So in this case, 13 minus 10, you will get 3. So 3 plus will be the charge of this cation. So now we go to the anion. So in order to get number of proton for this anion, we can simply just take the value at the bottom over here, which is proton number. So the value is 17. And to get number of neutron, we will do the same. We will use the same formula, A minus Z. So it is 35 minus 17. So the answer will be 18 number of neutron. And in order to get number of electron, still we are using the same formula, proton number minus charge. So we have 17 proton number minus the charge. You can refer at this symbol. So this negative meaning that -1. So 17 minus the charge. The charge is -1. So negative minus -1. So the answer will be 18 electrons. So the concept is similar to the 17 plus 1 because for an ion, atom will accept electron. So when accept electron, 17 tu you can simply tambah dengan 1 because number of electron now will be more than number of proton number. As the conclusion, in cation, number of electron will be less than proton number, and in anion, number of electrons will be more than proton number. In order to get the charge of the anion, we can simply do proton number minus number of electrons. So hence, you will get the value of the charge must be in negative. Isotope is two or more atoms of the same element that have the same number of protons in their nucleus but different number of neutrons. So we can take hydrogen atom as the example. So you can see at the bottom here we have hydrogen 1,1, hydrogen 2,1, hydrogen 3,1. Okay, or the other name is, this is hydrogen 1, protium, hydrogen 2, deuterium, and hydrogen 3, tritium. So this three form of atoms is actually comes from the same element, which is hydrogen. Okay, but they exist in 3 different atoms. Why 3 different atoms? Because they have different mass number. Why they have different mass number? Due to the different number of neutron. Okay, but they still having same proton number. So you can see the information in this table. For hydrogen, deuterium, and tritium, the number of proton is exactly the same. Okay, but number of neutron is different. Alright, so for hydrogen it is 0, deuterium is 1, tritium is 2. So to get the mass number over here, 1 plus 0 is 1, 1 plus 1 is 2, and 1 plus 2 is 3. Okay, so since this is neutral atom, so definitely you should expect the number of electrons should equals to the number of protons. And this is the example of isotope of carbon. So we have carbon 12, carbon 13, and carbon 14. So from this image, you can see that in carbon 12, carbon 12 has 6 electrons, 6 protons, and 6 neutrons. Meanwhile, in carbon 13, number of neutrons has increases to 7, and in carbon 14, the number of neutron has increases to 8 neutrons. So this will make the mass number will become 14. Okay, this is 13 and this is 12. Okay, so the most stable carbon in nature, okay, in this universe is in the form of carbon 12. Okay, carbon 13 is quite stable and carbon 14 is actually radioactive. Okay, so this is the way we write the isotopic notation for isotope. Here are the similarities and differences of the isotope. Isotopes are similar with each other in terms of number of protons, charge of the nucleus, number of electrons, and their electronic configuration. This is because they have the same number of valence electrons. Why they have the same number of valence electron and electronic configuration? Because they have the same proton numbers. And also they have the similar chemical properties. And for the differences, they will have different number of neutrons and they will have different relative isotopic mass. Okay, this is so sure. Why? Because when they have different neutron number, the value of A will be different. So A will refers to the isotopic mass. Okay, and also they will have different physical properties such as boiling point, melting point, density, fusion rate, and so on. Okay, so what you can see in this image, we have caffeine molecule, we have theobromine, aspirin, sucrose, citric acid, and menthol. So all these are called molecules. So what is molecule? Molecule is combination of 2 or more atoms. Okay, combination of 2 or more atoms. Atoms are jointly held by chemical bonds. Diatomic molecule contains only 2 atoms such as H2, N2, O2, Br2, and so many more. And for polyatomic molecule, it contains more than 1 atom in the same molecule. For example, O3. So O3 consists of 3 oxygen atom. H2O consists of more than 2 atoms. We have 2 hydrogen atom and 1 oxygen atom. So this is polyatomic molecule. Okay, for diatomic molecule, di meaning that 2. Okay, di meaning that 2. So in diatomic molecule, it is actually a molecule that forming from the combinations of only 2 atoms. So O2 consists of 2 oxygen atoms. HCl consists of 1 hydrogen and 1 Cl. Okay, carbon monoxide CO also consists of 1 carbon and 1 oxygen atom.
Thank you for watching, everyone. I hope this video could help to enhance your understanding in chemistry. Have fun in your learning and remember, chemistry is easy and fun.